More math examples. Let's see. How much heat? So boom, we're looking for Q. Does it take to heat up 8 grams of ice from negative 10 degrees C to 0 degrees C, assuming none of the heat melts the ice? So that means no latent heat. So that means we're using Q equals m Cp delta T because there's no phase change. Because no phase change. Okay, and we're looking for Q, so let's collect our variables. M equals 8 grams. Cp, I've got to look that up from my handy-dandy periodic table. Let's see. It's freezing, or melting, or whatever. Heat of fusion. So 334 joules per gram equals 334 joules per gram. You could also use calories, because it just says heat. It doesn't say what unit. And then delta T equals final minus initial, so 0 degrees C minus negative 10, so negative negative makes positive. So delta T equals 10 degrees C. Let's plug it in. Q equals 8 grams times Cp, which is 334 joules per gram, times delta T, which is 10 degrees C. Oh, there's a degrees C here. Wait, did I look at the right thing? Cp? Oh no! I did not look at the right thing. I looked at the latent heat of fusion of water. I need the specific heat, and it's not on here. Oh no. You guys better go look it up. I guess that's what I'm going to have to do now. See how I said, oh, the degrees C is not going to cancel out. That's how I knew that I had the wrong CP. So there you go. Alright, so let's open a web browser and let's Google the specific heat capacity of ice. Ice, ice baby. Ooh, look at that. What is it? 203? 9 more rows? What? What is this? What is this? Aha! Ice. So, 2.3. I guess it's just two decimal. It's got 2 dots. A little typo, I guess. 2.03. So let's just approximate it as 2. So it's 2 joules per gram degrees C. Let's plug that guy in there. 2 joules per gram degrees C. So gram cancels, degrees C cancels. We get 2 times 8, that's 16, times 10 is 160 joules. And there we go. So we can put in a sentence. It takes 160 joules to melt, or no, not to melt, to heat up 8 grams of ice from negative 10 degrees C to 0 degrees C. Ta-da! Okay, number 2. What is the specific heat of something which absorbs 67.5 joules of energy to increase 15 degrees C? The sample weighs 5 grams. So there we go. That's Q. Increase 15. So that is the change. That's not a final or initial. That's just a change. And the sample weighs 5 grams. That's an M. And what is the specific heat? So we're looking for Cp. So we have Q equals m Cp delta T. You could do algebra and rearrange this to get Cp equals Q over m delta T and then plug in. Most students have more trouble doing algebra when there are no numbers, so for most of you I'm going to plug it in first, but if you're advanced, try rearranging it first. I think it's easier. So 67.5 joules equals m. Do we know m? Yes, we do. 5 grams. Times Cp. Do we know Cp? No, we're looking for Cp. Times delta T, 15 degrees C. Alright, now to get Cp by itself, we have to divide by everything that is not Cp. It's currently being multiplied. So let's do the opposite, which is division. We got to do that to both sides. That's a rule of algebra. Miss Wynn will come find you if you break it. And I'm scared about what she'll do. I don't know. So now we have 5 times 15. I'm too lazy. 5 times 15. 75. So then we have 67.5 divided by 75 gives us 0.9. So this is 0.9, and the units are joules per gram degrees C. You could put in a sentence on your own. I'll see you in class.